Hello, we are now looking at chapter 6, which is about applications of integrations. So, the first application we are looking at is the area between curves. So, here is what we are thinking about. Like, we have two curves, and one of them is above the other throughout the interval. So, here on the left, I see let f of x be greater than or equal to g of x. What does that mean is that it could be a curve like this, where f touches g at some point or at more than one point it could touch, but not goes below g. So f stays above g all the time, or it might be equal to g at some point. In that case, what is the formula for finding the area between the curves? So what do we mean between the curves? This area. And bounds between A and B. So how can we find that? Think about it like this, that we take the area of under F. What does that mean? In this area, in the area between F and bounded above by F, function F, and bounded below by the x-axis. So this will be the area under F. And we subtract the area under G, which is going to be this area. So what is left is the area between the two curves. So this is our A. I hope this makes sense. So I'm now writing it as A is equal to integral from A to B f of x dx. Why? Because remember, this is the way we represent area as we learned in chapter 5. So this is area under F, or between F and the x-axis, minus the area under G. And now we can put them in one integral. Again, the reason is that bounds are the same and the function have the same variable. So we get this as our formula for finding the area between two curves. So if you know which curve is above and which curve is below, then this is how you can find the area between the curves. Now this is not something new. By the way, and the area will always be positive if we do this thing, f of x minus gx, if the function f is always above the x-axis. Similarly, over here, we have done this before when we were finding the area under f. So below it is bounded by x, axis, or the y is equal to 0. So the equation of our x-axis is y is equal to 0. So we see this will be the area, and we can think of it as area between f of x and 0. So in these cases, both of these cases, the area is always positive. Always positive. Because we are separating the smaller area from the larger area. Smaller positive area from the larger positive area. The problem can happen when you have this situation where the area is above in some portion of the interval and it is below the x-axis in the other portion. So then we might end up getting a positive area or a negative area, or we could even get a zero area, depending on which one is the has a higher value, or if they have the equal value. So how can we find the area? So if I find this integral a to b f of x dx, then it will give me what we call the net area. This is equal to the net area. The net area could be positive, could be negative, could be zero. So how do I find the total area? So think about it. Between the interval a to c, which function is above, or which function is the upper function? F of x is upper, and the x-axis is the lower. So I can write the area from a to c, between a and c, as integral from a to c f of x minus 0. Area above minus area below. So function up minus the function below. But in the second portion or the second part of this interval from C to B, we have this x-axis is above and the function is below. So we can write it as 0 minus f of x from C to B. Then we will get a positive answer, positive area. We'll get these two added. So this can be now written as a to c f of x plus c to b negative of f of x. Yes. So this is the same thing as to find integral from a to b absolute value of f of x dx, which is supposed to be the total area. So you can, if you split the function f of x, the way you will write as a piecewise function, you can use this, or you can use this information that you check where the intersection is, and then use this information that we always to get a positive area, we always subtract the lower function from the upper function. And so you don't have to worry about this absolute sign. I hope this makes sense. So let's look at some examples. First example is a very, very simple one where you are given everything. You are given that the function is bounded above by this function and below by this function and on this interval. Not always this will happen. So this is just to see how we are doing our calculations or what are the steps. So we have to find area between these curves. Now, if you can draw a picture, it will be very nice. But if you cannot, it still is okay for these examples because we are given everything. So we say A is equal integral. So where do I begin? 0. What is my f? Where does it end? At 1. And then here, which one is above? 2x plus 5. And then which one is below? The negative x cubed. Now, when you write these, so this was our kind of f of x in the formula. Keep these in parentheses. Negative x cubed. And why is it important to keep parentheses here? Because the second function, if that has more than one term, and if you don't distribute the sign, then you just write it like that, it will not be correct. So for example, if we had x cubed plus 1, and if we didn't put these brackets and we wrote it like this, then we will get different answer, completely different answer. So just make it a habit of always keeping the parentheses even if they are not needed. Dx. So dx, remember, is going to be on the whole thing even if I didn't put them, but it is a good idea to put some kind of brackets there. So this now becomes integral from 0 to 1. I can now remove the inner brackets or inner parentheses. 2x plus 5 minus x cubed. Again, you can remove these ones as well and just put dx there. So now if I integrate, I get x squared. So 2 times x squared over 2, 2 and 2 will get cancelled, plus 5x minus x to the 4 over 4. And then limits from 0 to 1, which is equal to, so this goes away, we have just x squared. Now if you from the beginning saw this, then we don't have to write this step. You can directly from here come to this. And now we plug in the limits. First the upper limit, then with the limits also we should remember the brackets. So 1 squared plus 5 into 1 minus 1 to the 4th over 4 minus 0, so it will give me all zeros, but it's better to write. So this is giving me 1 plus 5 minus 1 over 4 and then minus 0, which will be 6 minus 1 over 4 or 23 over 4. That is your area between the two curves. Let's look at another example. So this says find the area between y is equal to x squared and y is equal to x plus 6. So we don't know which one is going to be above. So first thing we do is, here, notice here, we are not told which one is above and which one is below, and we are not given the bounds as well. Now, it could happen that if they are saying that find the area between these two curves, it means they meet at some point. So we have to find those points of intersection, and then we can set up our integral. So how do we find that point? We don't need to find the whole point, we need the x coordinates. So what we do, we set the two curves equal to each other. For step 1, we set them equal to each other. So we get x squared is equal to x plus 6. How do we solve it? So this is a quadratic, so I can write it, bring everything on one side. So it gives me factors as x minus 3 and x plus 2. Which gives me x minus 3 is 0 or x plus 2 is 0. Which gives us x is equal to 3 or x is equal to negative 2. So we got 2 points of intersection. So it means we have one curve is above the other curve throughout this interval. So there will be only one integral. So now we have to figure out which curve is above and which curve is below. So there is a smart, this method. What you can do is draw your interval. This is -2, this is 3. So take a test point in between, for example, 0. What is x plus 6? At 0, the value will be 6. What will be the value of x cubed? Will be 0. Sorry, x squared will be 0. Which one is bigger? X plus 6. So it means this is positive above, x plus 6 will be here, and x square will be below. So that our area will be equal to, so what are the bounds? From -2 to 3. And which one was above? X plus 6. So we say x plus 6 minus x square. But again, remember parentheses. Now you just need to solve this. So let me do one more step here, and I will leave for you guys to finish the integration in your time. So we are removing the parentheses here. So it will be x plus 6 minus x square, and then dx. Okay, so you guys will do it, and then I will come back and check with what you have done. So let's move on to the next example. It says find the area bounded by y is equal to x cube and y is equal to x. Again, we are not given any bounds, and we are not told which one lies above the picture. Now in this case, we can easily draw our function. So the line y is equal to x goes like this. The y is equal to x cube comes like something like that. We have a small area over here and this same amount over here. So we have 3 points of intersection, if you notice. So our first job is to find the point of intersection. So even if you didn't draw this, it's okay, you have to find the points of intersection. How do we do that? We set them equal to each other. So we say x cube is equal to x. And now we have to factor. Now remember, do not do this step that you divide by x, and you say x square equals 1. Don't do that because you will lose some important intercept. So instead, we should bring everything on one side, and which will give me x cube minus x is equal to 0. And now we should factor x into x square minus 1 is equal to 0. for x into x minus 1 into x plus 1 equal to 0, which gives me x is equal to 0, x is equal to 1, and x is equal to negative 1. So now we have 3 points of intersection. It means there is a change of sign somewhere. Sign of the function will change, and we will get 2 integrals. Now, if you have drawn this function, you don't need to do that table that I showed you earlier. But if you didn't draw the function, then you should do the table, because from this picture, you can already see that in this interval, in the interval negative 1 to 0, in this interval negative 1 to 0, the function x cube is above the line x, and in the interval from 0 to 1, x is above and x cube is below. So you can easily set up your intervals. But if you didn't have this, then you should do this. So negative 1, 0, and 1. But we are not concerned about after 1 here and before negative 1 here, because we have to find the area between, and the area between only is here and here. Yeah, so we pick a point, sample point, for example, negative 1/2. So when x is negative 1/2, well, x will be negative 1/2, and what is x cubed? It will be negative 1/8. So you see, in this case, negative 1/8 is bigger than negative 1/2. So here x cubed will be above and x will be below. In the second interval, we pick x is equal to 1, x is equal to 1/2. So here x is equal to 1/2. So x cubed will be equal to 1/8. Now here 1/2 is bigger, so x and then x cubed below. Now you can set up your integrals actually. So we get a is equal to so I'll let you write the integral and then come back and see what you got. So integral, what is the first portion or first integral? It is from negative 1 to 0, and we have x cubed is above, so we write x cubed first, minus x, again, because these are single terms, so I'm not putting parentheses, otherwise you must, and plus, now we have from 0 to 1, and now x is above, so x minus x cubed. Now notice here we cannot put them in one integral because the limits are different and the functions are different. So now just you have to integrate it. So we get x to the 4 over 4 minus x squared over 2 from -1 to 0. And then plus x squared over 4, x squared over 2, sorry, minus x4 over 4 from 0 to 1. Now plug in the numbers and you get the answer. Okay, so let's do this one. So we have 0 minus 0 minus. Now the lower one. So -1 raised to 4 over 4 minus -1 square over 2 plus plus, and I want to change the color here just to show you. Plus, now I will be putting the bounds in this one. These were the bounds for the first one. So 1 square over 2 minus 1 to the 4 over 4 minus 0 minus 0. We end up getting, this is 0 minus. Now, -1 to the 4 is positive 1. We get 1 over 4 minus -1 whole square is 1. So 1 over 2 plus 1/2 minus 1 over 4 and minus 0. So that we are left with -1 over 4 plus 1/2 plus 1/2 minus 1/4. Is equal to, so if I take the common denominator to be 4, I have -1 plus 2 plus 2 minus 1. So I get 4 over 4 4 minus 2. So we get 2 over 4. Which is 1/2. So this is how you do this problem. Okay, next I will stop here, and there is one more example which is a little bit different. I will do that in the next video. And also I want you guys to finish the previous example where you have to integrate and plug in the limits.